right, so population growth. We're going to talk about two different kinds of population growth, and one is exponential and one is logistic. So, first thing I'm going to do is show you the difference between these two. So, exponential growth, it starts out maybe a little slow, but then it gets really, really, really fast really quickly. So, notice it kind of looks like a J or J curve is what people call it. So J curve. Okay. And then logistic growth, it starts out that way, but then it starts to level off. And then it sort of does this number here. Okay. So this is not really an S, but to give it a letter, they call it an S curve. Okay. So the reason why they look like this, I'm going to start with the logistic side because then the exponential side is just the opposite. So logistic, the reason why it looks like that is because there are limits to growth. So the logistic growth, there are limits to that growth, whereas with the exponential, there are no limits to growth. Okay, so the limits cause this to level off right here. Okay, so the limits make it stop at that red dotted line. Okay, so you have done this before because I promise you, you know this term because this term is called the carrying capacity. Carrying capacity. So that is the level at which a population stops growing in size. So it stays consistent in size because of limited resources of some kind. So it could be limited food, limited shelter, limited water. If the population's too big, it could be that they're really prone to diseases, things like that. So carrying capacity, that is your limit. Due to lack of resources. Okay, so that's the limit due to lack of resources, okay? So that term is really, 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 really important. So the reason why there is a limit in logistic growth is because of that carrying capacity. Okay, so that is that red dotted line. So that's where it levels off. So notice with the exponential that it does not do that. So it continues to grow faster and faster. Infinitely. Okay, so it'll keep growing. It'll keep doing that forever according to that model. So recognize that that obviously is not a real thing as far as the actual forever part. But most populations, especially when we're talking about like invasive species, so like the kudzu that's found on the side of the road, that's totally covers a blanket over all of the trees and all that on the side of the road. It is basically growing exponentially. It's growing as fast as it can because there's nothing at this point that's limiting its growth. Whereas if you have something like I don't know, a certain number of mice in an area, there might only be a certain number of places they can burrow or whatever. So they would start leveling off because at some point they would run out of shelter. So the note I want to make here about the real difference between this, I'm going to make a little box here. All right. So when a population first colonizes an area, it grows exponentially. Okay, so it grows exponentially. I ran out of room there. That's bothering me. I don't like that. X, I'm just going to put X, EXP. Okay, so no limit. Because it hasn't run out of its resources yet. Okay, but then eventually, eventually that it's going to start running out of room, starts getting close to the carrying capacity limit. And so then it slows down and levels off. Okay, so the limits there, just to make a list here: food, shelter, disease, etc. So there's a bunch of things that could cause that limit. So notice here, it sort of looks like at this point, and I'll use green because it sort of looks exponential right here. So along this point, it sort of looks exponential. They're basically nowhere near their limit at that point, so it's going to grow pretty fast. So far from limit. And then it starts to slow down as approaches limit. And then here, it hits the limit, and then growth halts. Now notice that I do have it fluctuating a little bit at that point, because it can overshoot, but then if there's too many organisms, then some more are going to die. And then if it's back under the line, then you're going to make more babies, and then so on and so forth. So eventually it'll kind of stay sort of on average around that carrying capacity limit. So that is population growth for biology 1. And so the differences there are whether there's a limit or not. If there is not a limit, it's just going to grow super, super fast. And it's going to continue growing faster and faster and faster infinitely with exponential growth. So it looks kind of like a J. So we call that the J curve. And then if there's a limit, when it starts to approach the limit there in blue, then it will start slowing down. And when it hits that limit, it's basically going to come to a halt. And the number of organisms each generation is going to be about the same. So maybe your births and your deaths are about the same. So it ends up averaging out to that same number time after time. So that is population growth.